This is Sleepy Time Tea by Celestial Seasonings. And it's been steeping for a good amount of time now. This is heavy cream. I've recently become enamored with heavy cream. And so I'm going to put this in here. There. I still don't know if it's going to be cool enough to drink, however. Let's find out. Wow. There's a little floaty in there. I'm gonna just assume it's tea. Oh, that's really good. I put a couple other things in there, but that's our secret. Last time we discussed theories of the fourth dimension, and since then I've thought a lot more about it, and I wanted to share some of those thoughts. I am an artist. I'm not a theologian or I'm not a physicist, though there have been physicists on my channel that left some comments that said that my thoughts were not totally off the mark there. So I just get this stuff from my head, I suppose, so I'm going to think more about it. I have some ideas. So one of the ways I like to think about a dimension that is outside of our reality, or the reality that we can perceive, outside of our perception, is we can theorize about the second dimension and the first dimension, and there being no dimensions. And if you can really, really understand the relationship between the second dimension and the third dimension, theorize how it could actually exist, not just in the math on the chalkboard or in numbers, but if looking around at our world, where would we actually find the second dimension in the third dimension? Two. Over here we have 4. Here we have 3. Here we have 1. And here we have 0. Now, we know that for there to be one dimension, it means that there has to be, that there's a point, and there's a point, and the one dimension is the ability to travel from one point to the next. Where 0 is simply a point. And if there's no dimension, then everything is nothing and nothing is everything. That's something I theorized last time. Everything being nothing and nothing being everything. It's really difficult for us to wrap our heads around this, but I think that might be one of the basis concepts of how the universe works. All is everything and nothing at the same time. When you have two dimensions, I'm going to draw this as a circle because I think we've seen too many squares. I'm going to draw this as a sphere. I'm going to call that a sphere. Does that look like a sphere? Oh boy. There. This looks like a clock, but it's not. So let's think about the relationship between the second and third dimension. Look at my hand here. My hands. Right here we have hands. We have a pencil. We have paper and this graphite. We have the desk. We have these candles. Now there's names for all these things. Why is there names for all these things? Because the molecules are organized into groups. Right? There's a certain amount of molecules that are all grouped up, and that creates the glass right here. Or this ceramic coaster. Or the various parts of this pencil. But what is causing each of these to hold together? To hold together, because we know down at the molecular level, it's all kind of the same stuff, right? Not at the molecular level, but beyond that, I think. Everything's made of the same stuff, but it's grouped and organized to form different elements, and so even the air around here has its own molecular structure. It's made out of its own thing, gases, oxygen, and yet my hand that is made up of certain groupings and materials from those groupings cannot go through here. There's a rule. There's a rule in place saying my hand cannot go through this pencil. And when we think about the second dimension and the third dimension as being a square and a cube, which I don't like it. I prefer maybe something like let's say this is just a flat circular thing, and this is a sphere. Oftentimes, this is considered to be, it's so flat, it does not have any mass going this direction. It's so flat, there is no mass. And you would want to say then, well, if it's so flat, how can it even exist? How can the second dimension even exist? It's so flat. Once you get flat, so flat, so flat, it just disintegrates, right? And that's why I think the second dimension is not like a slice. It's not a slice of this 3D matter. Like Carl Sagan was talking about. It's not a slice that's taken out of this 3D matter. It's actually the force which separates this 3D matter from this 3D matter. It's the force. The second dimension is the force that allows three-dimensional matter to exist, to be grouped, and therefore not be a blob. A blob, the entire universe, just a blob. Here, it's likely a blob. It's all everything and it's nothing, and this is probably before the Big Bang. Separation. And the grid by which the third dimension, the grid by which matter in the third dimension separated from itself and created a million different types of things. It lives on the 3D grid of that is made of second dimension force. Let me dig a little deeper into that. So I'm not that excellent at drawing so much anymore, but so here's a hand. This pinky seems to be bigger than that finger. We're not going to worry about that too much. Here's a hand, and actually let's not give it any three-dimensional details at all, because what we're talking about is the grid by which this hand is separate from the oxygen gas outside here. What is it? O2? I think I remember that from school. So this right here, this line right here that I'm drawing, that is the second dimension. It is the dividing force. It doesn't have mass itself, but it's simply telling that what's over here and what's over here do not intertwine. They do not intertwine. They shall not. And same, let's see if we have a fingernail here. This fingernail and this finger shall not intertwine. Maybe around here in the bed of the nail where things are being created, but even down, all the molecular level and everything like that, there is a grid of two-dimensional force keeping everything separate, keeping it all separate, keeping this cup. See, while the milk can intermingle with the tea, the three-dimensional grid, that is the force of the two-dimension, holds all these items separate. So it's between my finger and this cup. Now, if I worked hard enough, maybe I could, if I did this enough, maybe they'd fuse together. I don't know. This is a weird drawing. I don't know what this part is supposed to be. It's supposed to be more like that. Something like that. So that's my theory of the relationship between the second dimension and the third dimension. And you could also say that, let's say, if three dimension is, say, this orb, the second dimension is this network that divides the orb from the gas. Is the force. Then the first dimension is the grid that allows this force to exist. So it would be, so here's our second dimensional force. It's just, here's the rest of here's our mass. And this is sort of creating the power to keep this oxygen from this orange. And so this is like this web, this is network. But in order for this network to happen, there has to be the ability for these points to connect. So the first dimension is the network is each of these trajectories, each of these lines. It creates the web. It allows the force to be a force. It allows the force, the first dimension allows the force to exist. The second dimension allows the third dimension to have shape. And without any of these, everything is nothing. Nothing is everything. The points for the force for the shape. Now let's try to think. All right, so we're going to try to think about if this is true. If this is true, then what's the relationship between the third dimension and the fourth dimension? So This would mean that the thing, let's put the 3. Put a little 3 here. 3 and 4. 3 and 4. 3 and 4. Well, the 3 must be a grid. The 3 must be a grid for which the 4th dimension exists on. Our world of matter allows there to be a 4th dimension. Now, see, my theory is when we talk about 0 and 1 and 2 and 3 and 4 and on, my theory is there's exponentially less amount of this than there is of this. And it makes sense. It makes sense. You think of like a stack of papers, this kind of common analogy. A stack of papers, and then you also have the brick that stack of, the whole ream just makes this solid brick. There's a lot more pieces of paper than there are of this brick. Now, I guess it's the same amount of paper that there are to a brick. So I guess in third dimensional terms, you could say, okay, well, it's the same amount. But I theorize that you're getting exponentially smaller as you're moving along here. See, here you have stack. So here we have a paper. And it's made of infinite amount of lines going this way. Infinite amount of lines. So you have to factor infinity, and everything you do, I think, everything is going to be infinite. Everything. I think that's the law, one of the laws of the universe. Everything is infinite. So then everything is infinite. How can you have more than something else? Blow my mind. But I think what it is that it's more like a force. It's not like something you count. It's not countable. So we can count things in the third dimension here. So this would be something like a series of points. Yeah. A series of points that make up a line. A series of lines that make up a plane. A series of planes that make up an object. A series of objects that make up. Carl Sagan presented a tesseract, or actually he didn't present a tesseract. He talked about a tesseract as being something that's impossible to envision or maybe even imagine, but he showed what he said would be the shadow of a tesseract that we could visualize, because, and that's the theory, that if you have a three-dimensional object, it casts a two-dimensional shadow. I don't know. I mean, that's just a play of light. I don't know. I don't know. See, I don't want to attribute a two-dimensionality to a shadow. I don't want to attribute that because that's just light or the lack thereof. Maybe it's related, but not the way they're talking about it. I don't know, it just doesn't ring true. What's this look like? So a tesseract looks like something like that. Or it's a cube inside of a cube. But there's something to that, the cube inside of a cube, right? And it's not, see here, these are flat next, and all of these make up this, right? But these don't have mass. So in the fourth dimension, there's something about our world of mass, our material world, that stacks on itself. Now, one of my big theories is that the fourth dimension has something to do with scale. Scale is the only trajectory that's the most obvious when we're talking about this mathematically, you know, x, y, z. And then you have size. That potentially could be a trajectory, another trajectory of the size. You know, all this. As it increases, maybe, and I've thought this, maybe the fourth dimension. So let's see, if you're in three-dimensional world, you can travel around here. But if you're in the fourth dimension, you get to travel down. You get to become larger and smaller. Carl Sagan used the example of the apple that visits a two-dimensional universe, and this little two-dimensional being sees this apple as this because that's all that there is. I mean, that's really applying three-dimensional thought to this. I mean, it's a little, it's kind of, I don't know, seems a little childish. Just because we can slice an apple like this with a knife doesn't mean that the natural grid by which this apple is an apple and not the oxygen around it is a flat slice like that. I mean, honestly, it's probably more like bulbs, fractals. Everything grows in these fractals and spirals and spheres. when you look at the fractals, the bulbs, you can see that let's see if I can, maybe not. You can see that the big is the same as the small. In fact, when you're on mushrooms and you experience your mind fractaling, your thoughts fractal, your thoughts break off into I remember feeling this just this past year. I did a lot of mushrooms, and each thought that would come out of my head would it would go in all these different directions. So the force is a fractal, I believe. The force that holds the objects together, the two-dimensional force that holds the objects together is like more like fractals. And you know, man, this I mean, you watch enough of this and you'll get really disoriented, because we need there to be scale. We need there to be buildings. You know, we need there to be buildings, and we need there to be houses, and we need there to be airplanes. Oh, this is like a 9/11 reincarnate. Let's just say, just for our own sanity, this flies around. We need there to be pencils. We need there to be all these things. When we see if we see a pencil that's like as long as a block, it really screws with us. Scale is really important for our sanity, I think. That's why if we see like a person who's like particularly little, well, we think a lot of different things. We think they're cute, or we are, it scrambles our sense of reality. We're challenged by it. And so yeah, there's something to the idea that the fourth dimension trajectory, I'll call this W, is size. And that if you're able to move in through the fourth dimension, you'd be like shrinking down and expanding. So you'd be traveling. It'd be like Honey, I Shrunk the Kids. You'd be traveling through size down into smaller things, into smaller things, into smaller things, into larger things, and larger. I don't know. I'm not convinced by that. There's something more to this relationship here between the second and the third. The second being the grid by which the third is separated. Can our third dimension be the bone structure, the framework for which the fourth dimension exists? Well, here's an idea. So here's our world, just hanging out. Inside this world, there's a plane, and there's buildings, There's little cars. But the fourth dimension, maybe, it does have to do with that concept of there being multiple universes or multiple dimensions. Perhaps in the fourth dimension, there are versions of us, versions of everything that are just different. You know, this one's going to be called A, and this one's going to be called B, and there'll be another one over here that's called C. And it's all kind of made up of the same stuff, but if you were able to travel in the fourth dimension, maybe you'd be in the same place, but just everything would be different. So we would suggest that all the stuff that's in all the stuff here is like the sandbox for which there's a little shovel sticking up here. All the matter inside here is the sandbox for which it becomes expressed in infinite different ways. Maybe it's not infinite, maybe it is finite. But in many, many, many different ways, using all the same stuff. You know, because they like to say that energy just kind of transmutes or it changes into different things. That there's a finite amount of matter in the universe, and then there's a finite amount of universes in which that matter can morph into different things. But then we're talking about a timeline here. You know, in order for that to be true, at what point did it begin? And maybe it begins with the Big Bang. And that begins the timeline. Here's where we are here. And in the fourth dimension, there are all these timelines. Then that's the question about the fifth dimension. Oh boy. Oh boy. And there's maybe infinite number of these. Infinite number. So the fourth dimension is the infinite or finite amount of different expressions for the matter which exists inside here. The B, the C, the D, should connect there. The E. You know, and that kind of makes sense. Like, and they're all stacked up on top of each other, you know? It's all within the same space. It's all within three-dimensional space. Let's do that. And then there's another one right there. See that? It's all in the same place. It's all right here. Well, I think it's enough thinking for one night. I'll see you next time.